Hi everyone, welcome to my end of the semester summary for Physics 112. I have to say this physics class was a lot different than my Physics 1 class and a lot of other science classes that I've taken, but in a good way, and I'll also discuss a couple of things that I didn't like about the class. So I want to divide this up um, into four parts. First, I want to talk about the actual physics that we learned during this course. Then I want to talk about how David encouraged us to discover things on our own and some of the things we learned from that. I then want to talk about some of the things that I didn't like about the course. And then I want to talk about our controversial debates, which I think was one of the most important things that we did in this course. So, let's start with some of the actual physics and calculations that we did this semester. So, in week 2, we did a gravitational versus electrical forces assignment. I'm going to show it here. So basically what we were doing was calculating the difference between gravitational and electrical forces. So we used two equations to do this. We basically looked up masses and charges for electrons and protons, and then figured out what electrical forces were acting on them. So these are my calculations here, and basically we learned that the electrical force is infinitely stronger, 2.27 times 10 to the 37th power times stronger, which is a lot stronger. So that was one of the calculations we did. Another one that we did is we worked with circuit stickers. So this is a really interesting little activity booklet that we ordered that basically had a lot of ways that we could connect LEDs with electrical tape in certain configurations to basically learn how batteries and electricity work. So this is one of the activities we did here. It was a simple circuit template. It was interesting because we had to make sure that the electricity had a continuous path to go through. Oops, that's a picture of a foster dog. That's not the picture we want to see. Okay, anyway. So it was a really interesting exercise and kind of challenging also. We did an activity called Nervous About Nerves, where we basically modeled the human body with LEDs and electrical tape and sort of decided what things need to be connected nerves-wise to innervate organs and major organs in the body. So here's a picture of one of the diagrams of the body. So another calculation physics thing we did was called optic fun. So basically we learned about presbyopia, which is basically when you become very nearsighted and you can't see things that are close, and it's basically when you're 40 or 50 and you have to hold things far away from you to see. So what we did is use the thin lens equation to figure out why when a lens ages, it's not able to be flexible and focused on objects that are close, and why it is that when you move the reading material farther from you, you're actually able to focus on it. So that was an interesting exercise too. So those are some of the highlights of some of the more physics-oriented activities that we did. And I want to talk about the things that we did that were more research oriented, where basically David would give us a topic to discuss and we would discover things on our own. So the first one I want to talk about was quantum mechanics, which we did in week 4. So it was called Quantum Superimpose Yourself. So we watched a TED Ed video, which kind of gave you a synopsis of quantum mechanics in a layman's terms. We talk about Schrodinger's cat and what that means quantum physics-wise. Basically, why you could put a cat in a box, transport it through the universe, and figure out whether it would be alive or dead when you open the box. So I really enjoyed how when we looked at TED Ed Talks, we would go into the delve deeper portion where we would answer questions like I'm showing here, which really makes me think about what you just read and how to relate it to things that you already know or have already learned in other physics classes. Here are some of the questions that we went over with the quantum mechanics video. And it's very interesting. I mean, quantum mechanics is sort of mind-blowing, and we kind of can't relate it to physics right now on a bigger scale. Macroscopic physics is hard to integrate with quantum physics, but it's important, I think, to understand both of them. Another thing that we did discovery-wise were the Elegant Universe videos on string theory. So we did those in week 5, and it was a series of, let's find it here. It was a series of 3 videos, which basically were an introduction to string theory. So we did a quick synopsis of each of the videos and kind of tied it together at the end. Here are my notes. Here on the screen, the first video talked a lot about the beginning of sort of physics theory and the most important physicists, Newton and Einstein and Maxwell, who first hypothesized black holes, the beginning of string theory, how it was very discredited in the beginning, how these new, tinier than ever we thought could imagine particles began to be discovered, the different dimensions of string theory, and what I thought was really interesting is how in the 1980s we basically had 5 versions of string theory that had been created, but the problem was we couldn't connect them together. And in episode 3 we learned more about how they sort of were tied together, and basically how physicists are still trying to create a unified string theory, and things like Fermilab, those scientists are conducting research to find traces of strings and just actual concrete things that we can build a unified theory of string theory around. Another thing that we did discovery-wise was our cultural science experiment, where I wrote a paper about The Greatest Show on Earth, The Evidence for Evolution by Richard Dawkins. It's an extremely good book, I think, even though I find Dawkins to be pretty biased against creationists. He's a pretty brilliant evolutionary biologist that I think is known for his snarkiness. But it really does even if you think you know about evolution, you haven't put the pieces together exactly how he does in this book. And I think it kind of encompasses a lot of different disciplines: genetics, anatomy, embryology, and really shows how we can see evidence of evolution in all of these things. And of course, because he pretty much this hates creationists, he debunks a lot of creationist arguments. And you might not like the language that he uses, but the evidence he gives is pretty convincing and really just an interesting way of looking at everything as to um, things are beautiful without needing to have been designed, basically. So that was one of my favorite parts of the course, was writing a paper on this book that I really enjoyed. So really quick, a couple of things that I found about the course that I wasn't so excited about were the posts about, is college valuable, how students today are wasting their time. I know that these things are definitely points of contention in education today, but I don't necessarily believe that they belong in a physics class, where what I want to do is learn about what you, as a physics professor, knows and can teach me about science. I do think it's the student's responsibility to use education and the cost of education wisely, and to research this on their own. So I can't say that I was excited about those posts, even though they are good to know, and I know that not everyone is aware of these issues. So moving on to our controversial debate, I think this is definitely one of the best ways to stimulate thinking about science or any subject, is to research things, debate it, and try to see other sides. The two most important debates I think we did were on fetal stem cells and should intelligent design be taught in schools alongside evolution. They're super controversial, and I think we all were scrambling to research things that sort of proved our point either way, either side that we were on, and I think that that's the best way to learn. I just want to end this with actually a really short Stephen Hawking video, where I think he kind of encompasses why we be taking physics class or any class, and why we should be curious about the things around us. This is him speaking at the 2012 Paralympic Games, and I think what he has to say is just super inspiring.
When a bandit has been a public figure, the state must tackle special.